Hello students, up till now we have studied two operations on vectors, that is number 1 addition and number 2 subtraction. Now this is the time to study about the product or multiplication of two vectors. We are having two types of multiplication in vectors. One is dot product and second one is we call vector product or a cross product. It is very interesting to know that when we are talking about vector product, then the resultant of the product will be a vector quantity, and when we will do dot product or we can say the scalar product, the product or you can say the resultant will be a scalar quantity. So let us discuss about both the products one by one. In this video, I'll continue only with dot product or scalar product. So let me start dot product. As I told you that the resultant of the product of the type scalar is the scalar quantity. But how will we get this? Let us discuss. We are having two vectors. Let me name vector A and vector B. And let theta be the angle between these two vectors. Let me draw these vectors for you. This is one of the vector. Let us say vector A, and another vector B, let us have with us. This is vector B with us. Now certainly these two will make some angle between them, and let this angle be theta. Then the product of these two vectors is expressed as in the form of dot product A dot B. We will put dot sign because we are talking about dot product. So we will put dot in between them. You should be careful about it that there should be no sign other than dot. Means we can't use this sign, we can't use this sign like bracket. So these should not be used. When we are talking about dot product, it should be strictly A dot B. So you should be careful about writing the dot product or the vector product that we will discuss. So A dot B, that is the dot product of two vectors, is expressed as modulus of vector A into modulus of vector B into cos theta. Here when I am calling into, so it is simple multiplication because now magnitude of A and magnitude of B will be nothing but simply the constant or the scalar quantities. So in other sense we can write it as AB cos theta. A is the magnitude of vector A and B is the magnitude of vector B, and cos theta is the cos of angle made between the two vectors. So this is how to represent dot product in terms of angle between them. Now let us find A dot B for the different values of theta. So number 1, let me take when theta is 0 degree. So when theta is 0 degree, obviously we have cos 0 degree as 1. So therefore A dot B is equal to modulus of vector A into modulus of vector B into 1. So simply we are having AB, means magnitude of A into magnitude of B is simply A dot B when angle between the two vectors, between the direction of two vectors is 0 degree. Next thing is when this theta is 90 degree. Theta is equal to 90 degree, means the two vectors are perpendicular to each other. So as you know very well that cos 90 degree is 0. So now I think you understood what will be the value of A dot B. A dot B is equal to 0 because A into B into 0 is 0. So this is very important condition for calculating or for applying when the two vectors are perpendicular to each other. Whenever something is missing among the two vectors A and B and it is given that the two vectors are perpendicular to each other, then directly you can put A dot B is equal to 0, and from there you can easily find out the missing values. So we are going to use this result in many of the questions. The next thing is when theta is equal to pi, or you can say 180 degree. So you know very well that when theta is equal to 180 degree, then cos 180 degree is equal to minus 1. So therefore A dot B is equal to minus AB simply. Okay, so the value of A dot B, that is the dot product, changes as the value of theta changes. So for the different values, suppose theta is 60 degree, theta is 30 degree, 45 degree. So as the changes I have written over here, the same changes you can write for the different angles. On the basis of this discussion, can you find out the value of A dot A, means when a vector is having dot product with itself. Do you know what will be the answer? Yes, the answer is modulus of vector A square. Why this is so? Because A dot A means vector A into vector A, modulus of these into cos 0 degree, because angle between the same vectors, that is A and A, is 0 degree, and it is nothing but simply 1. So therefore modulus of A into modulus of A is modulus of A square. So one thing you should always keep in mind, that whenever you are having modulus vector A square, do not write it as A into A, means using this sign. You can never use this sign, okay, or any other sign. Like you also can't write it as in the bracket. So you should always be careful that when we are talking about modulus of vector A whole square, it means we are talking about A dot A. I am emphasizing on this because students usually did this mistake. They do not take care of this thing, and they write A square, vector A square modulus as either this, or they are not aware that how to write, and they are simply write it in a wrong way. So you should always be aware what I have told you. Next thing that we can find out from this dot product is the angle between two vectors, and it is very easy for you now, I think, as we have vector A dot vector B is equal to modulus vector A modulus vector B cos theta. So simply cos theta is equal to A dot B upon modulus vector A into modulus vector B. So from this result only we can find out the angle between the direction of two vectors A and B. The next thing that I would like to add over here is, what is the value of I cap dot I cap, J cap dot J cap, K cap dot K cap, or this is one of the pair when we are having the same unit vectors I, J and K and their dot product. The next thing is, if we are having I cap dot J cap, or we are having J cap dot K cap, or we are having K cap dot I cap, or we are having J cap dot I cap, means for all the pairs that will be possible from all these three, we can have any of the pair for that. Now first of all, let us talk about I dot I. As just I discussed, for the vector A and A, means A dot A, if we are calculating, the angle between these two is 0 degree. Similarly, the angle between I itself is 0 degree. So what will happen? It is I cap modulus into I cap modulus into cos 0 degree, and cos 0 degree is 1. So simply we are having I cap modulus square. What is I cap? I cap is the unit vector along x-axis, Therefore, its modulus is 1. Its magnitude is 1. So, therefore, the resultant that we are getting is 1 over here. Similarly, for j dot j and for k dot k, we are having the resultant as 1. Now, let me discuss one of these. Let me take I cap dot j cap. So, it is I cap modulus into j cap modulus cos. What is the angle between I and j? 90 degree, because I is the unit vector along x-axis and j is the unit vector along y-axis, and these two are perpendicular to each other. So, therefore, we are having cos 90 degree. So, the resultant that we are getting is 0, because 0 multiplied by anything is 0. So, similarly, every pair which is having the different unit vectors, the resultant is 0. So, I hope you understood how are we getting this thing and how can we use the dot product and angle between the two vectors. Now, let us discuss about geometrical interpretation of dot product. That is, how can we represent dot product geometrically, and let us visualize it by using one figure. Here in this figure, I have taken one vector OA directed from O to A, and let me name this as vector A. So, let me write vector A is equal to vector OA. Second, I have taken vector B, that is OB directed from O to B. So, we are having vector B is equal to vector OB, means directed from O to B, and theta is the angle between the vector A and vector B. Now, by using geometrical interpretation of dot product, we will be able to find out one more additional result over here, that is how to find out the projection of one vector over the other. So, let us discuss how can we have this. So, as we know that A dot B is equal to modulus vector A modulus vector B is into cos theta. From the figure, it is clear that modulus of vector A is length of vector OA, means we can write modulus vector A is equal to OA, means this is the length, okay, or you can write A like this over here. Next, modulus of vector B is equal to OB, so this is OB, or we can say B over here, because modulus of A and modulus of B can be simply written as A and B. So, we can write it as A dot B is equal to AB cos theta, or we can write is equal to A into. Here in the figure, if we look over here, then OAQ is right triangle, right angled at Q. So, what will happen if we use trigonometric concept in this triangle OAQ? We will be having that cos theta is equal to base upon hypotenuse, that is OQ upon OA. We are talking about here only length OA and length OQ. So, from here we are getting OQ is equal to OA cos theta, and OA is what? OA is A. So, we are having A cos theta. So, if we use this A cos theta is equal to OQ over here, then we will be having A cos theta into B. Let me write it as this. So, what we are getting? We are getting B into OQ. We can write in this way also, because here we are using simply the product. This is not the product between the two vectors. Now, let us have a look on the figure, that what is OQ in the figure. So, this OQ is nothing but simply the projection of vector A on vector B. So, OQ can be written as projection of vector A on B. So, let me write it over here. In place of OQ, we can write projection of vector A on vector B. So, from here we are getting that A dot B, that is the scalar product of two vectors, is the product of magnitude of vector B and the projection of vector A on vector B. And from here you can derive the formula of projection of vector A on vector B is equal to A dot B upon modulus B, or simply B you can write. So this is what? This is scalar projection. This is scalar projection of vector A on vector B. If we need to find out, let me write over here, this is scalar projection. This is scalar projection. Now if we are talking about vector projection, so as I told you that when we need to change a scalar quantity into a vector quantity, we need to multiply it by unit vector. So similar wise here, it will become vector projection if we multiply it with B cap. So by unit vector of B, if we multiply this scalar projection, we are going to have vector projection. So this is how to represent dot product geometrically. One thing more that you should know, that this is the projection of vector A on projection of vector B. Now if we need to find out projection of vector B on A, projection of vector B on A, if we are talking about, it is simply vector A dot vector B upon modulus vector A. And if we are talking about vector projection, then multiply it by A cap. So in this way you should be careful that on which vector we are calculating the projection. On the particular vector on which we are calculating the projection is in the denominator with modulus sign, and to get the vector projection, it should be multiplied with the unit vector of that vector only on which we are calculating the projection. Now next, let us come to the properties of scalar product. Number one property is commutative property. So as we know that the dot product of two vectors is a scalar quantity, so therefore A dot B is equal to B dot A. So the dot product remains same if we interchange the position of two vectors. So we can say that dot product is commutative. The next property is the scalar product of two vectors is associative with respect to scalar. What does it mean? If we are having a scalar M, vector A and vector B, then what is the meaning of associative with respect to a scalar? It means M into vector A dot B is equal to M into A dot B, or this is also equal to A dot MB. Means to say this scalar can be multiplied either with directly first of all A, then having dot product with B, or first of all we can have dot product and then multiply by the scalar, and the third one, this M can have multiplied with B first of all and then having dot product with A. So therefore the dot product is associative with respect to the scalar. The third property is the scalar product of two vectors is distributive with respect to addition. What does it mean? Let me write it. This is the third property, or third property which is distributive. So this property states that if ABC are three vectors, then A dot B plus C or minus C is equal to A dot B plus or minus A dot C, whatsoever the sign over here. If plus sign is here, plus sign. If minus sign is here, we are having minus sign over here. So we are having three properties. Number one, dot product is commutative. Number two, dot product is associative with respect to scalar. And number three, the dot product is distributive with respect to addition, or you can say subtraction. Now the next, let us discuss about the analytical form of scalar product. To find out analytical form of scalar product, let us write vector A and vector B in their component form. So let A1, A2, A3 are the scalar component of vector A. So we have A1 I cap plus A2 j cap plus A3 k cap as the component form of vector A, and vector B, if having B1, B2, B3 as the scalar components, then we have B1 I cap plus B2 j cap plus B3 k cap as the component form of vector B. Now just as I told you that I cap dot I cap is equal to j cap dot j cap is equal to k cap dot k cap is equal to 1, and I dot j cap, I cap dot j cap is equal to j cap dot k cap, and so on, as just I discussed, the value is 0. So if we multiply, if we find the dot product of A and B over here, that is, let us write A dot B. So let us find out dot product of A1 with all these three first. So we are having A1, B1, these are the scalar, so get multiplied in this form, and I cap dot I cap. The vector quantities, that is I, will have dot product in between them, and scalars will multiply like the scalars. Plus the second term will be A1 B2 into I cap dot j cap. The third term is A1 B3 into I cap dot k cap. Next, if we multiply A2 with all these three, then A3 with all these three. So in this way we can multiply. Now let me discuss only for these three. Rest of the things you will understand yourself. Now A1 B1 I cap dot I cap. I cap dot I cap is 1. So we are left with A1 B1 over here. Here I cap dot j cap is 0. So the whole term will be 0. Similarly, here I cap dot k cap is 0. So the whole term will be 0. So this is 0. So similarly, if we multiply this A2 with all these three, so j cap dot I cap is 0. J cap dot j cap is 1. So this term A2 B1 will be 0. Means this multiplication of these two, dot product of these two will give us 0. But we are left with A2 B2. And similarly, A2 B3 j cap dot k cap is 0. Then we multiply, or we can say that dot product of A3 k cap with these three. So this will give us 0, these two will give us 0, these two will give us 0. Only the thing which is left with us is A3 B3. So finally, analytical form of A dot B we are getting as A1 B1 plus A2 B2 plus A3 B3. So simply we can say that analytical form of dot product of two vectors is the sum of the coefficient of I cap, j cap and k cap in both the vectors. We can find out angle between the two vectors, as just I told you that A dot B is equal to AB cos theta, and from here we have calculated cos theta is equal to A dot B upon modulus A modulus B. So this can also be represented in analytical form, and this will be A1 B1 plus A2 B2 plus A3 B3 upon modulus of A. And what is modulus of A? It is square root of A1 square plus A2 square plus A3 square, and B1 modulus is B1 square plus B2 square plus B3 square and root of it. So let me write it for you. A1 A2 plus B1. So cos theta can also be written in an analytical form as A1 B1 plus A2 B2 plus A3 B3 upon a1 square plus a2 square plus a3 square root of it into b1 square plus b2 square plus b3 square and root of it. Now let me discuss some more important results on the basis of dot product. As I told you that a dot a is equal to modulus of vector a square of it. Similarly, if we need to find out a plus b, vector a plus vector b modulus and square of it, so clearly you will write it as a vector a plus vector b dot vector a plus vector b. Okay, you should always use dot product over here. And now after getting this thing, you are getting modulus a square because this is a dot a. So it is modulus a square. Then plus b dot b, you will get modulus b square. Plus when a vector multiply having scalar product with b, you are having a dot b, and next you are having b dot a, and just we have studied that this is commutative, a dot b is equal to b dot a. So the result that we are getting is modulus a square plus modulus, here it is b square, plus 2a dot b. So similar wise you can calculate for a minus b whole square as well as a minus b dot a plus b. Next result is a vector dot b vector and square of it. Its value is less than or equal to modulus vector a square modulus vector b square. This result is also known as Cauchy-Schwarz inequality. Cauchy-Schwarz inequality. Let me write it for you. So this is Cauchy-Schwarz inequality. How to prove this inequality? Let me write it for you. As we know that a vector dot b vector is equal to modulus vector a modulus vector b cos theta. We need to find out here a dot b whole square. So let me calculate whole square over here. A dot b whole square is clearly modulus a square modulus b square into cos square theta. Now you know very well that value of cos square theta is always lying between 0 to 1. It is greater than 0 but less than 1. So if we put the value of cos square theta over here and we remove this cos square theta, then it can also be written as less than equal to modulus a square modulus b square, because when we multiply this quantity modulus a square modulus b square with a quantity which is less than 1 or greater than 0, then this quantity will be greater than a dot b whole square. You can say the value which is lying on the left hand side. So in this way we can prove this result, Cauchy-Schwarz inequality. The next result is triangles inequality. This result states that modulus a plus b is less than equal to modulus a modulus vector a plus modulus vector b. This is called triangle inequality, and this can be easily proved by taking squaring both side. Not both side, only calculating vector, I should write vector a vector b over here and square of it. It means, as you know, a plus b vector a vector b dot vector a plus vector b, and as just you have calculated, this is modulus a square plus modulus b square plus 2ab cos theta. Now as cos theta is lying between minus 1 to 1, so therefore this can also be written as less than or equal to modulus a square plus modulus b square. So revise these concepts very well so that you will be able to do all problems related to scalar product. In my next video, I will explain about vector product, and till then keep learning.